I stopped the last video just a little bit too early. And so we just got done graphing our first log function right here. And we now know the correlation between exponential and logs, that they're inverse functions. So they are symmetric with respect to that line y equals x. But just like I did with exponentials, and I wanted to show you kind of the similarities and what different graphs with different bases look like with a log, I want to do that same thing with logs as I did exponentials. So here is what we just graphed. Here's my exponential. Here's my line of symmetry. And here is my log. I'm going to click off my line of symmetry in that exponential. And here we have logs with different bases. So when I have a base of 3, here it is in purple here. When I have a log base of 4, so notice that these are getting flatter a lot quicker. Log base 5 gets even quicker. And that's all we'll do there. So notice that they all have a lot of things in similar. They both now, instead of having a y-intercept that's the same, now they have an x-intercept that's the same, all crossing at 1, 0, no matter what that base is. Also, they both have a vertical asymptote right here of x equals 0. Now, what happens when I change that base to something less than 1 but bigger than 0? And they have a little bit of a different shape right here. You can see now that's decreasing faster because notice it's getting more shallow, decreasing faster and decreasing the fastest. But no matter what that shape of that graph looks like, they still are all crossing right here at 1, 0, and they still have that same vertical asymptote. It's just one's going up and one's going down, but they still have the same vertical asymptote. So a lot of similarities on logs, even when they have different bases as far as x-intercepts and vertical asymptotes.